these are the notes for 5.7 part 2. It's just a continuation of the first part of 5.7. So it's the same thing. We're just given a random factoring problem and we've got to figure out what strategy to use to solve it. So all I'm going to do is do 1, 2, 3, 4 examples with you and then give you 2 to try on your own. So let's see if we can make these a short video notes. So pause this if you need to write this down. Same as yesterday, so I'm kind of looking at those first part of the notes I took yesterday where I wrote down the general factoring strategies. And the first thing you always want to do is factor out a common factor if you can. So on this one, if I look at all three of those numbers, 12, negative 40, and negative 32, I can factor a 4 out of all those numbers. I think it's the greatest common factor. Even if you're not sure, just try it and you might recognize automatically if you can factor something else out. So we're going to factor out a 4. So I'm left with 3x squared minus 10x minus 8. Then I want to look at what's in the parentheses and ask myself, is there a way I can factor that? It's 3 terms, so I can see, is this a perfect square trinomial? And I can already see that 8, this last term, is not a perfect square, so it's not a perfect square trinomial. So then I could try x squared plus something x plus c, but the problem is I have this 3 in front of the x squared, so that means let's try AC method, because it's in that form, something x squared plus or minus something x plus something. So let's try AC method. So we're going to do a times c, 3 times negative 8, and that is negative 24. So I'm trying to find something that multiplies to negative 24 and adds to negative 10. So let's see, I can do 1 times 24, I can do 2 times 12. Ooh, 2 and 12 seem like they might be able to get me negative 10. Since I'm trying to multiply to negative 24, one of these two numbers has to be negative, either the 2 or the 12. Since I'm adding up to a negative 10, I know the bigger number needs to be negative. So 2 and negative 12 are my two numbers I'm going to use. So I'm going to rewrite this part in the parentheses, but I'm going to replace that negative 10x with plus 2x minus 12x and keep the 3x squared and the minus 8 the same. Keep in mind that we still have that 4 on the outside. We really don't want to forget that. If it was a test, I might even go ahead and write the 4 on my answer line to make sure I don't forget it. So since I'm doing a C method, I'm going to factor this part by grouping. And my first pair, I think I can pull out just an x, right? And I'm left with 3x plus 2. I just took an x out of each of those terms. So in our second set of parentheses, I need both of these terms to end up positive, so they match these. So I know I need to take out a negative because that will switch those signs. And let's see, what goes into 12 and 8? 4, right? So I can take out a negative 4. Negative 12x divided by negative 4 is positive 3x, and negative 8 divided by negative 4 is positive 2. So what I have right now is I kind of have all of this in brackets, and I have that 4 on the outside still. Don't forget that 4. So for my next step down here, I'm going to go ahead and write that 4. Then we can factor out this 3x plus 2 out of both of those terms. So I'm left with x minus 4 in my other parentheses. And I think I'm done. If I check what's in those parentheses, I don't see any numbers that have common factors within one set of parentheses, and nothing has any powers, so I know I can't factor it anymore. I am done. So there's 1 out of 4 examples done. For our next example, we're going to factor 3x plus 12 plus ax squared plus 4ax. So if I look at this one, I don't see any common factor out of all those terms, unfortunately, other than 1. So then I look at how many terms it has. It has 4 terms. So let's see if we can factor by grouping. Let's see. Out of these first two, I can pull out a 3. So I'm left with x plus 4, because 12 divided by 3 is 4. In my second group here, let's see, remember I'm trying to get x plus 4 in my parentheses. So I think I'm going to be able to. I think I can pull out an a and 1x from each of those terms. So then I'm left with, let's see, in this first one, I'm just left with 1x. And in my second one, I factored out the a and the x, so I'm just left with that 4. So this is looking good so far. So now since I'm factoring by grouping, I can pull this x plus 4 out of both of those. Remember, I kind of pulled it out in front. So then I'm just left with 3 plus ax. All right, 2 down, 2 to go. All right, so now we are going to factor y squared minus 9a squared plus 12y plus 36. All right, so when we look at this one, nothing I can factor out of everything. And when I look at this, I'm kind of thinking one of these guys is not like the other. One of these things is not like the others. The thing that's kind of weird is that 9a squared, or the negative 9a squared. So I'm wondering if I could rewrite it and like stick that guy at the end. So I'm going to write y squared plus 12y plus 36. So I just wrote that part so far. And then let's put this minus 9a squared guy at the end. So I just reordered it just now. I just moved that minus 9a squared guy to the end. So now I'm seeing something a little nicer here. If I just look at that part that I wrote in black, the y squared plus 12y plus 36, if I just focus on that, I think I can factor that as a perfect square trinomial. So this part right here is a perfect square, I think, a perfect square trinomial, because this first term is y squared. My last term is a perfect square. It's 6 squared. So my middle term has to be 2 times this times this. 2 times y times 6. That's 12y, and that is my middle term. So that part right there is a perfect square trinomial, and I can factor it into y plus 6 squared. So all I've done so far is I factored just that part of my equation, the first 3 terms. It was a perfect square trinomial. So I factored that part, and it's y plus 6 all squared. Now, so all I've done is simplified the part that I wrote in black. This part in green, the minus 9a squared, is still there. I still need to deal with that. So now, let's look at this and see if we, because this is not all factored. We don't have all things just being multiplied by each other. We have this just minus thing sticking out here. So it's not all factored. So if I look at this, now I have 2 terms. There's a minus in between them, so it's a difference. And I think it's a difference of squares. So I think what I have right now is a difference of squares. So we want to just keep looking for any kind of factoring that we can. Because this first guy is exactly what it says. It's y plus 6 squared. And the second one is 3a times itself. 3a times 3a is 9a squared. So what I have here is a difference of squares. So I'm going to factor it just like I normally would. I'm going to have this guy plus this guy. Let me scoot down a little bit. So I'm going to have y plus 6 plus 3a. And then I'm going to have this guy minus this guy. So y plus 6 minus 3a. And I didn't have to do the parentheses or anything because there weren't 2 terms in the term that I was subtracting. When I subtracted 3a, that only has 1 term. So I didn't have to worry about parentheses and distributing a negative. So now we're done. There's nothing I can factor out of all 3 terms in either of those parentheses, and nothing has any powers, so I know I'm done factoring. All right, one more together and then 2 to try on your own. So for our last example together, we're going to factor x cubed minus xy squared plus x squared y minus y cubed. So I've got a 4-term polynomial here. I don't see anything I can take out of all 3 of them. I don't think I'm going to get a perfect square trinomial in here because I don't see anything that's a perfect square. So since it's 4 terms, let's try factoring by grouping. out of these first two, I could pull out an x, right? So I'd be left with x squared minus y squared. And then in this set, I could pull out a positive y, and I'd be left with x squared minus, oh, y squared. Nice. So I just took a y out of that and that. That's what ended up in here. All right, so now this is looking nice. When I'm factoring by grouping, I can pull this out in front. So I've got x squared minus y squared I'm factoring out. And then I'm left with x plus y. Now, I have a feeling a lot of people would stop right here, but look at both of those. This one in black, I don't think we can factor anymore, but the one in red, that's a difference of two squares, right? So I can factor this one in red to x plus y times x minus y, because those are the two things being squared. And then I've got this x plus y on the end. So then the only thing you want to do to really make sure you write this in the most simplified thing is, since we have an x plus y times an x plus y, we can just write that I have x plus y squared times the x minus y. Let me know if you have questions about how I just did that. So I'm going to give you guys two problems that I want you to try on your own, and then just come to class with any questions you have. So here's the two I want you to try. The instructions for both of these are just to factor it as much as you can. So question A is 8n squared plus 2n minus 15. And question B is x squared minus 4x minus 16y squared plus 4. All right, give those a try and come to class with questions, and we're going to do some major practice with factoring.